Assalamualaikum and good day everyone. We continue our discussion with conductor, free space, boundary, condition. Okay, due to the name, we know that we have two material which are conductor and free space. Okay, let's assume our first medium is free space. And our second medium is conductor. If you still remember, the boundary condition number 1 equation is d1n minus d2n equal to rho s. Okay, to make analysis on this equation, we recall the property number 3, conductor under static condition, where in that property, we agree that our E net is equal to E applied plus E induced equal to 0. So, this one is suitable for conductor material. And in this case, which one is our conductor? Yes, this one is our conductor. Because of this statement, we can say that our D2n will become 0. So that the boundary condition number 1 will equal to the D1n equal to rho s. Okay, so that one will be our final equation for the boundary equation number 1. Okay, for the case conductor free space boundary condition. Okay, now look at the boundary condition number 2. Okay, that one is the tangential component, and the equation is E1t equal to E2t. Okay, and again, refer to this one, we can say that this will be equal to 0 since no E in a conductor. So, we can write here E1t is equal to 0. So, this 2 is the final equation for the conductor free space boundary. Okay, for the conductor free space boundary condition, we know that we have two equations where D1n equal to rho s and another one is E1t equal to 0. So now we want to look at how we can analyze this D. Okay, let's give a situation where we have this kind of boundary, and this is the medium number 1 and this is the medium number 2. And here we have the surface charge at the conductor. Okay, because the medium number 2 is our conductor. So we have the surface charge here. Okay, and I label it as a rho s, the surface charge density. And we know that this should be, or the D for this should be perpendicular or normal to the boundary. So let's say this is the D here, so this one is supposed to normal, and about this one it's supposed to become like this because we want to get the normal vector here as this one. Okay, and this one can write as D, okay, vector D equal to rho S times an unit vector. Okay, where this one, okay, the rho S is a magnitude, where this magnitude is based on the surface charge density only, while this one is the unit vector, which is normal to the boundary, and the D here is electric field density in free space. So we get the final equation of the electric field density in free space in the situation of the conductor free space boundary condition. Okay, you can just use this equation. You don't need to prove it when you want to solve the problem. So that's all for this video. Thank you.